Problem 36, Sudoku, valid Sudoku. So we basically have to check validity of a Sudoku board. We don't have to verify whether it can be solved. We just need to verify that it is in a valid state, which basically means that there are no repetitions. So there are no digits are not repeated in any row, any column, or also in any of these 3x3 boxes that are highlighted by these black borders here, right? So there are 9 rows, right? 9 columns, and also 9 of these boxes. And each of them contain 9 elements. So each row contains 9 elements, column contains 9 elements, and also this box, which is 3x3, contains 9 elements as well. Right, so how should we, well, before we proceed, we should say a couple of words how the input is provided. The input is provided as a single array board, which is an array of two-dimensional array, a matrix of strings. So every element itself is a string. It's a number wrapped into a string. Empty cells are represented by a single character dot. And this will be, everything will be fine here in the sense that there will be no weird characters. We don't have to verify whether one of those cells contains unusual characters like W or something like that. The only thing we need to verify is that there are no duplicates in rows, columns, and all of these boxes. Now, just a small note how you access elements in this matrix. Well, it's kind of easy if you realize that this board is actually on the surface, it's just an array. And for example, if you take any of these elements, let's say element with index 0, then you would get this thing. This is its first element with index 0. So you'd get this entire thing. Now, when you look at this thing, whatever you got back, right, this would be what? So this would be board 0. And if you look at this board 0, you would get, as we said, this thing back. Now, what is that? This is an array, actually. So if you wanted to access this element here, then in this array, you would just do normally the square brackets and 0, 1, 2, 3, 4. Okay? So effectively, to access an element in row 0, column 4, 0-based indexing, you do this. Board 0, 4. Row first and column next. Now, this row first, column next, just a convention in the sense that there are no rows and columns inside computer memory. This is just how we usually represent matrices on paper. So board 04 is board is drawn in a way that the first index kind of represents row. That's usually done. I mean, just a convention. All right, now, how do we deal with this problem? So one way to deal with this problem would be to go through each of these cells. First row, all the way, then the second row all the way. That would be 2 nested loops, right? So R and C. So from the outside, I'd put row, and then column would be an inside loop. And let's say we are at some point looking at this element here, or Why don't we actually look at this element? Makes slightly more sense, right? So we look at this element. So row here is 3 and column is 4, I think. Yeah. So row 3, column 4. If you look at this element, then if it's an empty cell, then we don't do anything. Just go to the next iteration. Otherwise, if it's, let's say if it's this digit 6 here, then if I had a set dedicated to this row 3, then I could inquire, then I could look inside the set and say, does that set already contain number 6? If it does, then I could instantly return false, because that would mean we've just invalidated, we just realized the board is invalid. Otherwise, I would look in column 4, and let's say I also have a dedicated set for this column. And I could say, well, do I already have number 6 here? So again, I would return false if number 6 is already there. But I also have to do the same for these boxes as well. Okay. So somehow I should be able to say, well, I should have a dedicated set to this box. And I could say, well, do I have this number 6 in my set, which represents this box? So if all of those return false, sorry, if all of those queries say, no, you don't have number 6 in in the row or column or box, then I could just add 6 to all of them. I could add my 6 to this row, to this column, to those sets that are dedicated to remembering what we've seen in these rows and columns so far, and also for this box, and just go to the next iteration. Okay. If I get out of that loop successfully, then I can return true, because I haven't found any problems with this board. So why have I selected a set to represent this? Because set can have every element just once. I could also use an array, which would be faster. So maybe I would actually use an array instead. But maybe I'll just show you how to write this with a set, and then if it's not fast enough, we can upgrade it to a faster array. So one problem would be, since we're going to be dedicating sets to each row, that's easy. I mean, we can just put them in those sets in an array. So we're going to have 9 sets. So we'll just put them into an array and index them by the index of the row. Same for the column. So 9 sets for 9 columns. We can put these sets into an array and index them with these column indices. But how about these boxes? There are 9 of these as well. So we will have 9 sets for boxes. But how would we identify these boxes? Now, for now, just remember that we will somehow number these boxes like from 0, 1, 2, 3, 4, 5, 6, 7, and 8. So 9 of them from 0 to 8. And then somehow we'll convert these row and column indices to this. This is number 4, right? 2, 3, and 4. So we'll convert this to number 4, to the box index. So each time we're looking at one of these elements with row and column, we will always be able to identify which box we're looking at. Okay, so let's try to write this now. I'm just going to take this function over to typescriptlang.org. Typescriptlang.org has a playground, which is useful. It's a slightly better editor than whatever LeetCode has. So I'm going to write here. So first of all, let's create 9 sets for 9 rows. And we said we're going to put them into an array. So constant rows would be array. So that would create an array of 9 elements with all elements undefined. But I'm going to quickly map each of these elements to a new set of string. Now, if I do it like this, now my rows should have the correct type of this. An array of set of strings, each one of them. Good. That's rows. Columns, also the same thing, from length 9 and new set of string. Just one thing, notice that what I couldn't have done is something like new array of 9 elements and fill it with new set. Yeah, well, you could do that. This would not change anything, but the problem with this, aside from typing, I mean, this would not be correctly typed, and actually, even this would not help you. This would not help you. So instead, what you have to do is just say set of string. Now you're okay. Now type of this is the same as type of this, and this plays no role anymore. But I mean, this is not okay, because the problem here would be that inside this array, you should have 9 different sets. Instead, you have all of these elements pointing to the same set, because you took this one set and provided it into this function. So you provided a single set. So fill will not duplicate, will not copy, will not create copies of the set. It will just use the set that you provided to fill this array. So every 9 element of this array will be pointing to the same set. Which means if you were to say, well, I found a digit in one of the rows, then that, as soon as you say that, it would mean that you found it in all rows. So you add something in one of those sets, you effectively add it to all of them, because it's a single set. So that's the right way to do it, okay? But we also have to create 9 boxes, right? So the same thing for all of these 3x3 boxes. Again, same thing. We have that. Now we can go through all of the elements with 2 loops. Rows, we're going to iterate through rows and columns in a nested loop. So let row be 0, row is less than 9, plus row. For let column is 0, column is less than 9, plus column. Now here, if board row column equals the symbol for the empty cell, then simply continue. Otherwise, let's say digit equals board row column. We're gonna we're going to say parse integer. So we're going to extract that integer that's inside of this and do -1. Why? Because the integers are from 1 to 9. I want them from 0 to 8, so from 0 to 8, including, right? Do I want that? Well, this is a set, so I don't really need this. I could even don't even parse integer. I could just say this. Because it's a set of strings, I don't have to convert this to numbers. So just keep it as a string. So now what I will say, if rows row. Now rows row, this is the set dedicated to this particular row. So all sets for all rows dedicated to this particular row that I'm currently going. If it has D, then return false. If columns call has D, then return false. And let me just not forget to so if I haven't returned false here, then I need to add this D to these sets, preparing for the next iteration, saying that, well, I may not have seen this before, but now I have definitely seen this D, right? I've just encountered it. So I have to add to this row, add D. I'm basically adding this digit to the set that is dedicated to this row and also to this column, add D. But how about the box? Let's say index of the box be some number. It's just some number. We'll write this, whatever number it is. Remember that the index is this number 0 or 1 or 2. So that's the index of the box. Then we could basically do a very similar thing that we did for columns and rows. We could say if boxes with index bi has D, then return false. If not, we could say boxes with index bi add D. The only thing that remains is find out the index of this box. What is the index of this box? So this is the box, and it has index 4. And for this element with indices here, we have to somehow find the index of this box. Now, what I propose here would be, let's look at these big rows. This is a big row with indices 0, 1, and 2. Can I find the index of this big row? The index of the big row would be this index divided by 3, and then take a floor, maybe a different color. Okay. How about the index of the big column? When I say big column, basically I'm referring now to if you were to just zoom out and just see these big cells, 3 by 3 cells, and no longer notice the actual small cells, then what would be the row and column for those big cells? Where am I currently when I'm looking at this element? So the big column here would be column divided by 3, and we should take floor, which means we just take the whole number and ignore the fraction. So now we have these indices. So in this case, this is, what is this? This is 1, row with index 1, and also column with index 1. This would be 0, big column with index 1. So 1. Now, with these two numbers, 1 and 1, we have to somehow get to 4. Now, if you know different numeric systems like binary, tertiary, or ternary, this is clearly a ternary version of 4, if you can see it, because there are, if you can see, there are 3 different elements in each row, 3 different elements. So this 1 represents a second row after 3 elements. So this is like, so this 2 here is kind of, if it was decimal, to the last digit, like 9. And after that 9, you have, this is 10, which is 3 in ternary. And this is 11, right? So this 11, if you know these numeric systems, you could easily say that, well, I should multiply 3 by this and add this. So 3 times plus this. That's our rule to find the index of this box. I mean, even if you do not know how these numeric systems work, I mean, you don't have to do it. You still just remember that there are 3 kind of boxes in each big row. So you just multiply number of rows by 3. That gives you how many complete rows you have. This is how many complete rows, because this is 0 index, right? So if this is 0, then you have 0 complete rows just before this. So 3 times that would be, all of the boxes in all the previous complete rows. And then you are somewhere in maybe an incomplete box. And this is it. So that's our formula. Instead of none, here I would write 3 times math floor of row divided by 3 plus math floor of column divided by 3. And now I have to return true here. And that's my code. Let's take this to here, paste it, and try it on the pretests. Good. Now we can submit it. We've submitted it. Waiting for the verdict. So memory, we beat 88%. That's good. Now, if we wanted to still rewrite this for array, so here we would, instead of doing this, we would convert this to an array, which would be new array of 9 elements, because there are 9 digits, because we don't have 0, right? It's from 1 to 9. And we would fill it with zeros. Why do we fill it with zeros? Because we're going to count elements in there. And as soon as this count, so we're going to just increment the 0 to 1 every time we find an element. And if we come back and the count is not 0, so if we find that we're looking at some element and its previous count is non-zero, that means we've seen a duplicate. So now what's going to happen here is, now we need to convert this to an integer, because it will be, so for example, if you're looking at the number 9, we no longer can use this string 9. We should convert this to an integer. So parse int, and also -1, right? Because we don't have 0, there are no zeros in this board. everything starts from 1. So we need to bring everything down to 0, start from 0 so that they fit in this array properly. Now, this has D is no longer correct. We just need to say D, because now this is an array, and D now is a numeric index. Okay. Now we could do here. So we could do D plus plus. Yeah, we could do this. But why don't we just do this instead here? So why don't we just do it here? And what that would accomplish is, let me just get rid of this stuff. This is a post increment. Post increment, post increment. So I'm going to check, I'm going to take this value, check it whether it's already over 0. If it's over 0, I'm going to return false. But plus plus would increment this value after it was taken. Okay? So the value of this expression is the same as value of this expression. It just plus plus works kind of behind the scenes. It increments this after the value is calculated for this expression. So this is precisely what we want. So why don't I try this? Paste that one here and try it on pretests. Okay, this worked. Now I'm going to run this. It should be faster, at least not slower than this 3 milliseconds. Let's remember, so 3 milliseconds and 58 megabytes. 3 milliseconds, 58 megabytes. Six milliseconds. That is, well, memory improved. Speed actually became worse. That is very awkward, to be honest with you. That is very strange. Can I submit it one more time? This is very unusual. 5 milliseconds. Okay.